and we can turn it over to Daniel. Daniel Aparo will be showcasing why a few identity management tools are the best choice for continuous authentication in a zero trust environment. Daniel, all yours.
Thank you, Austin. Okay. Hi, everyone. I'm Daniel Opera, and today I'll be speaking on implementing continuous authentication in a zero trust environment using Zscaler and Okta. Now, a little bit about me. I was born and raised in Nigeria. I currently reside in California, and I'm an intern with the Delinear Palm team, working with my mentor, Dallas Walters. I'm very passionate about IAM and PAM, as I recently obtained my Okta Certified Professional certification. I'm a big sport fanatic, a Chiefs fan, and a United fan. I won't be talking about the Super Bowl today, though. I'm also an avid movie watcher, a music lover, and a bookworm. So I'll take you through my agenda for today. I'll be speaking on the differences between traditional versus zero trust architectures. I'll take you through the importance of continuous authentication in a zero trust network. I'll also take you through a Zscaler overview, what is Zscaler, and the specific Zscaler service. And I'll take you through the authentication process between Zscaler and Okta, and I'll take you through my demo on implementing continuous authentication. Last but not the least, will be the question and answer segment. Now let's dive in. So breaking news, tech giant Cerberus acquires IT company Danotech, and Cerberus plans to overhaul Danotech's traditional perimeter-based infrastructure and implement a zero trust infrastructure utilizing Zscaler. Now the aim is to enable secure private access for its users into internal applications. Now, I want to talk about traditional versus zero trust architectures. What do we actually mean? Now, a traditional architecture focuses on the concept of internal trusted networks. This is where your workloads, data, and resources are secured behind a network perimeter. It's very similar to a castle and a moat, where you have resources and people, treasures, protected within the high walls of the castle, and you can only access it via the moat. Now, the flaw in this setup is if a threat actor is able to bypass the moat and gain entry into the castle, they can get their hands on the treasures, harm the people, or spy on the people. We should also take into account the adoption of cloud security and the remote working. This has expanded the network perimeter beyond the castle walls, and this creates a security headache for organizations to deal with because now it becomes very expensive and complex to protect their resources in a fast becoming perimeterless world. This is where zero trust comes in. Now, a zero trust architecture operates on the concept of never trust, always verify. This is where resources and workloads are protected individually. The zero trust architecture doesn't focus on the network, but focus on identity. And when we implement it, it segments applications and data away from the network. Let's talk about the importance of continuous authentication in a zero trust network. Now, continuous authentication supports the main principle of zero trust, which is never trust, always verify. It's when implemented, it's it basically ensures that users and devices are always verified and authenticated against the policies and criteria set upon it. Continuous authentication ensures that or reduces the risk of compromised credentials, insider threats, and session hijacking. It does this by continuously monitoring device and user posture and behavior throughout the session. Now, there are 5 core principles of continuous authentication, which are verify explicitly, use least privilege access, assume breach, protect data, and monitor continuously. There's different ways to implement continuous authentication, namely via user identity, user location, the network user is logging in from, the application they're trying to access, the user's device posture, and data. Later on in my demo, we'll be looking at using device posture to enforce continuous authentication. Now, Cerberus plans to overhaul Danotech's infrastructure and implement zero trust using Zscaler. Now, the big question, what is Zscaler? Well, Zscaler is a cybersecurity leader in zero trust solutions. They provide seamless, secure, reliable connections for users to access internal applications and data. Now, Zscaler provides a wide range of services such as Zscaler Internal Access, Zscaler Private Access, and Zscaler Digital Access, Digital Experience, sorry. Now, let's look at one of the services Zscaler provides, which is the Zscaler Private Access. Now, Zscaler Private Access grants access to users access to internal applications without the need for VPNs. It does this by connecting users directly to private apps, which minimizes network exposure, reduces the attack surface, thereby limiting entry points for threat actors to exploit. With the ZPA, we can minimize attack surface, enforce least privilege, eliminate lateral movements entirely, prevent data loss, stop cyber attacks, and deliver a superior user experience. Now look at three key components of that enables user to access internal applications. And they are the client connectors, the Zero Trust Exchange platform, and the app connectors. Now the client connector is a lightweight application installed on the user endpoint. And what it does is it enforces security policies and access controls on the user's device, regardless of location or application. The Zero Trust Exchange platform enables this connection to take place between the user and the internal application. It makes use of the Secure Access Service Edge framework to create a secure cloud-native environment for users to connect directly to the internal applications. App connectors, on the other hand, they act as checkpoints that ensures that only trusted users are able to access internal applications directly. They also facilitate seamless and secure connection between users' endpoints and the ZPA cloud. And how they do this is by making sure the users are able to connect to the on-prem hosted servers or applications, virtual private clouds, or virtual networks. They also enable secure and authenticated interface connection between the internal servers, the customer's internal servers, and the ZPA cloud. Now let's look at the authentication process. So let's take a scenario. We have a user trying to, meanwhile, I'll point out that GPS actually uses Zscaler everyday use for the users and the organization. So let's take a scenario where we have the GPS employee, specifically an admin, trying to access on-prem data center application. Now, what the employee would do, they would authenticate using client connector to the Zero Trust Exchange platform. And whilst on the platform, they would establish a connection via the private service edge. And when a connection is established, they have to now download configuration settings that enforce access policies, access control policies, and security policies that make sure the user and their endpoint adheres to the permissions and privileges set by the organization. And when that happens, then the Zero Trust Exchange platform via the service edge connects the two outbound connections coming from the client connector and the app connector. They are linked up together, which enables communication and connection to the internal application. And the work of the app connector would then be to inspect inline traffic between the app connector, the internal application, and the user. And while it does this is to stop or prevent threats coming from the user or the user device. Now let's look at the authentication process between Zscaler and Okta. Now let's see the user, a GPS admin, will try to authenticate to the ZPA, and then he will be redirected, or they will be redirected to Okta to authenticate and verify that they are who they say they are. Now, Okta would require you to impute your credentials, and when you do that, Okta checks it against its database and verifies that yes, you are indeed who you say you are. And when Okta does that, it sends back a SAML assertion response to the client connector. Now the client connector in turn will take this SAML assertion response and a certificate service request. Now this certificate service request contains information about not just the user, but the device and its identity. And the client connector will take this and the SAML assertion response with it to the ZPA. And on the ZPA would verify that the SAML assertion response meets the criteria set by it, and then it grants authorization. It will also sign the CSRF certificate, which would in turn establish a secure tunnel connection via TLS between the client connector and ZPA. And this would carry with it the connection that would make the user be able to link up with the internal application. And when this is finalized, the client connector will be forced to download profile and policy settings on the client connector. And this profile and policy settings enforce security policies and access controls for the user on its device and the identity. Now I'll take you to my demo environment topology. Now we can see here that the client connector has already been installed on the user Polatridis' device. Polatridis is a Danotech DC admin, and he's trying to access the Danotech DC server located in an AWS environment. Now we can see on the AWS environment, an app connector has also been installed and is in connection with the Danotech DC server. Now, in my demo, I'll be taking you through the ZPA private access settings that would enable Polatridis connect seamlessly to Danotech DC. I'll take you through creation of a device posture profile that would set the criteria for the device Polatridis is using. I'll also take you through app segmentation, I'll create an access policy that links the device posture and user Polatridis and enforces security policies and access control for Polatridis and his device. Then I'll take you through the client connector authentication and how we are able to get onto the Danotech DC server. Last but not the least, I'll take you through digital experience and we'll check on the activities of Polatridis on the Danotech DC, specifically endpoint monitoring and application monitoring. So let's go dive in. So my demo on implementing continuous authentication. We'll start from the client connector and we'll create a device posture profile. Now, on this device posture profile, Danotech DevPos will limit the operating system to just macOS because Cerberus specifically gives out only macOSs to its employees. Now, the device posture criteria will be a file path on the Cerberus device for Polatridis, and the device posture would always check the device that Polatridis is using and make sure that the file is located in the file path. We'll save this setting and then we'll link the setting to the macOS policy. Now the macOS policy is what will be enforced on the device. And what we'll do here, we'll name it, we'll enable it, we'll also link a forwarding profile. Now this forwarding profile tells the client connector how to forward traffic to the ZPA cloud. Last but not the least, we'll also link the user Polatridis to this macOS policy. Now we'll save the settings and we'll move to the ZPA platform. Now on the ZPA platform, what we'll do is we'll create an app segmentation. Now this app segmentation, it delivers a precise user to app segmentation for the application we're trying to access. It puts the application in a segment and takes it off the network completely. Now, to do that, we could actually either use a fully qualified domain for the application or we use an IP address. This time around, we'll be using an IP address to point to the application. And when we do that, we also restrict access to the application via an RDP port 3389. And then we'll click on next. And when we are taken to the next page, we'll have to link this app segmentation to segment group. Now, the segment group is basically used to link similar domains or similar applications together for easier enforcement of policies. Now we'll create a segment group, a Danotech seg group, and we'll enable it, and then we'll go and click on next. In the server group, what the server group does is it also brings similar segment groups together for easier enforcement of policies. And when we do this, we'll now create an access policy. Now, the access policy basically is a way to enforce the policy together in a way that is unified. So what we do with this, we set criteria that the user and device must meet to be able to access the internal network application. Now, the three criteria that we're looking at today is application, user, and device posture. Now, for the application, we'll click on and select the Danotech AppSec that we created. And we can also use the app group if we want to. Now, for the user, we'll link the user PolarTridis to this policy. And for the device posture, we'll link the Danotech device post that we created. Now, what this is saying is that the user PolarTridis must be using a macOS operating system, and he must have that file path located on his device, and the application must be part of this AppSec for him to be able to access the internal application. Now, when we save this, we'll move over to the client connector and log in as PolarTridis. Now, when we log in, we'll go through the authentication process I previously mentioned, and we'll be redirected to Okta, where we have to input our credentials, and Okta verifies it against its database and ascertains that we are who we say we are. And then we'll be sent back to the ZPA with the SAML assertion, and we'll register our device and be granted access to the client connector. And we'll see that we have the privileges and the permissions granted by the organization. And when we look at when we click on more, we can see that the Danotech Mac OS policy is being enforced. Then we'll move over to the RODP. And on the RODP, we'll notice that when we try to log in with the public IP address of the application, we are unable to log in because the application has been taken completely off the network. When we try to log in with the internal IP, we'll be granted access, and we log in with an admin credentials. Now we see that we can be able to log in because we meet the criteria required. And then we are logged into the DC server. In the top right corner, you can see all the information there. And then we'll exit and test the device posture criteria that we created. Now, by testing it, we'll remove the file from the file path and see what happens then. Now we try to log into the DC server again. Now the device doesn't meet the criteria required to access, and we are restricted from accessing it. So we go back and put back the file in the file path. And what we'll notice is that now the device again meets the criteria required. This shows that continuous authentication is taking place behind the scenes based on the device posture criteria we created. So we'll exit, and we'll now go into the digital experience side of my demo. And we can see here that the PolarTridis device has been registered, and we can see all the functionalities and all the information required from the device. Now, this is part of the endpoint monitoring service that Zscaler provides. Now we'll go to the ZPA platform, and we'll check the application monitoring aspect of the ZPA. And you can see we access the application via the port 3389. And when we click on it, we can see we access it twice. And if you scroll down, we can see it's recorded there. And if we click on one of them, it shows us certain informations about the activities we performed. We can see the service edge, the closest service edge to us that we connected to, the location we connected from, the connection type, which is a ZPA, the time and date of our connection. And this brings me to the end of my demo presentation. Now, I would like to give a special thanks to Dallas Walters, my mentor, the Zscaler team here at GPS, Gianluca Bastia, Nico Bartolomeo, and the GPSU team. They were ever so helpful with my project. And also, I'll give a special shout out to my fellow interns who actually were, were there for me at all times. We're always there to boost me up when I felt low. And I also returned the favor, and I feel like I had a great internship with GPSU. Thank you.
I can echo that. Great internship indeed. Thank you.